Hello, this is Aaron Cook from Team 6699 Tempest, FTC team. This is a second series of basic RobotC programming, which will move into more advanced RobotC programming. The first series was lost in the deep abyss of my broken hard drive, so this is a second go at it. Hopefully this will be better than the previous one. Considering that I'm more experienced, I have like a whole another year under my belt. So, this episode is going to be very basic. There is going to be no programming involved. Although I would suggest before this next episode, get familiar with some basic ideas of programming. So maybe look up some Python stuff or something, like understand what a line of code is. But you don't need any of that for right now. We're just going to go through what you can do in the application. So, open up RobotC, wherever it is. It's right here for me. And the first thing you want to do, if you're with an FTC team, most probably your coach or your team or school has paid for a license, and you want to not use the 30-day trial, because after 30 days you can't do anything. So to start that up, go to the help at the top here, go to manage licenses, and click add license. And then usually it's 3.x for LEGO Mindstorms. It is possible that you have LEGO Mindstorms 4.x. I have 3.x. And then just put in your stuff. And then, as you can see, non-expiring, infinite days. I will black that out. Okay. So, that's how you sort of get everything set up so you don't have it accidentally shut down on you. When you open up, you might get a splash page. I have that disabled. You can disable that in View, Preferences, Show Splash Screen on Startup, and check that off because it's just annoying and unnecessary. And you'll be welcomed with this web page. Sometimes there's a small bug where if you have certain networking drivers installed, RobotC will not start if you don't have an internet connection. So if you're finding that you don't have an internet connection, RobotC won't start, try uninstalling specifically Hamachi drivers if you have LogMe in. Okay, so getting into the actual application itself, up here you have your toolbar. You'll mostly be using the Robot tab, and each of these does different things. So compile a program is what you do to check your code, make sure it works. Compile download program will compile a program and send it to your brain. Compile a target usually is a physical robot. If you have the virtual worlds, you can compile to a virtual worlds robot. There's a member on my team that had that. I've never tried it, but I know it's possible. Open debugger manually. These are for more advanced things, so once you get into writing some more code and stuff, you can get into the more nitty-gritty details of what's going on. NXT brick is a commonly used tab in here. Communication link setup basically allows you to find your brain through Bluetooth or connect to it from the USB cord, and it also is possible through Wi-Fi with a Samantha module. And then if you use joystick control FTC, it's kind of like running a mini field control system with your own robot. Platform type, this is very important. Let's change this right now. So by default, I think it'll have LEGO Mindstorms NXT picked. You don't want that. You want to go down here and select LEGO NXT Tetrix/Matrix, which allows you to use the Tetrix and Matrix controllers and sensors. Download firmware. So if you're moving from LabVIEW to RobotC, which probably a lot of you are, when you first plug your brain in, it will probably have the LabVIEW firmware installed. We don't want that, so if you connect to a brain up here, you can just click download firmware, standard file, and your brain will lose all of its previous programs, but will be able to work with RobotC, and test communication link as what it sounds like. Okay, so connecting to your robot, let's see what this does. If you click that, it will automatically try and search for Bluetooth if you have a Bluetooth card in your laptop, which I do. Most laptops do have a Bluetooth card. If you do not have Bluetooth, you can get a USB converter or dongle. I know some people on my team have done that. Up here, I don't actually have a brick with me. It's a bit odd that that's showing up in the results. But you'll see reachable bricks through Bluetooth or Wi-Fi on here. Any brick that is connected through USB will be up here. And then you can also see your history of selected things. And one quirky thing with the Bluetooth, if it's not connecting properly, or if it's not showing up properly, what you can do, go down here, go into Bluetooth, and you can add it to Windows. And when you add it to Windows, it will install drivers. So as you can see here, my brain is added to the Windows Bluetooth devices. So if you do that first, it will install drivers nicely, and everything will work better and smoother. So do this first. You just click Add Device, and it'll search whatever. So yep, do that. And then you go back here. It'll automatically search. Highlight your brain, select via Bluetooth if you want Bluetooth. You can also just click Select too. And then it'll say connected here or whatever. Sometimes you have to type in like the code. Default code for Bluetooth on a brain is 1234 unless you have changed it. So that's communication setup. The next big thing in here is the help option. So if you click open help here, you'll get this nice screen. And this is very useful. I would suggest reading through these. So general C programming for right now is probably one of the most useful ways to spend your time. This will sort of go through basic C programming. I'll be going through that too, but it's probably useful to refer to this as you go. And then it's just sort of like a manual. You can of course search. So if I search whatever NXT, it will send me a whole bunch of hits in the manual. So I can just like click here, and it'll tell you everything you need to know about the Samantha module and FCS setup and stuff. Very useful. It also tells you stuff about programming, so if I type in motor, it'll show me different examples of code on how to program motors and stuff. So if you're ever stuck, you're trying to write something cool, try looking into help. Okay. So this is pretty boring right now. We haven't written any code. I don't have any code. So let's get a new program going. So to do that, we will open a sample program. So if you click File, Open Sample Program, it will send you to the system files, which have sample programs. So let's just, I believe there's an FTC section. Yes, first tech challenge. Here we go. And let's open the sample autonomous program. So if you load this onto your robot, you can put your own code in here, and it'll run the autonomous. So this is pretty cool. I'll explain what's all going on in here later. You can read the comments. This green text is comments. It's not actually code. It's sort of like little notes you put in your code. So if you go up here, you can either double click. So what we're gonna do, we can either double click these progmas like so, or go to robot, motor, and sensor setup. It'll bring up this screen. So if you're writing your own new program or you're opening a sample, if you're opening a sample, you probably won't have to do this. But if you go into standard models, make sure you have no configuration selected. Sensor management, I don't touch that. Okay, for external controllers, if we want this to match your robot perfectly, select custom, and then sort of set up the way your brain is set up. So let's say you have nothing here. Okay, so you got nothing on S2 or S1, but let's say your motor controller is connected to S3 for some reason. So you have one motor controller, you have two motors. If you go over here, so we added the controller. If you go over here, you can name your motors. So you want to name them something that is easy to refer to because you're going to have to refer to them. So say your right motor and your left drive motor. Simple as that. And it should automatically select Tetrix motor. I'm not particularly sure. I think you can select matrix. Yes, you can get matrix here. I use Tetrix, so I'm not very experienced with matrix. These options over here can be useful. PID control can only be used if you have an encoder. So let's say both of the motors have encoders. PID control should be only used for very specific things. PID control is nice if you want to go to a very specific encoder value, but if it's something like drive motors, generally PID control will just mess up your speed and stuff. So generally for drive motors, I don't do PID control, but encoders, I like to have motors with encoders on them. Encoders are the things that you put on your motor and will track how many rotations it has, and there's like a whole extra cord that connects to the controller and stuff. And then this reverse thing, so RobotC, when it sends a positive value to a motor, so if you say go forward, positive value is turning clockwise. So if I say positive to my right motor, it will go forward as I expect. But if I say positive right now to the left motor, it will actually go backwards because positive is clockwise. But if you check this reverse thing, you can send positive to the left motor, and it'll go counterclockwise, which is forward on every setup. You don't need to know how to send positive and stuff, but it's just something nice in the future to have. So, yeah, that's about it for this. If you have, let's put a servo controller in here. So if we have, let's say we have a servo controller daisy chained to our motor controller. You can add servos, so there's standard servos and continuous rotation servos. Let's say we have one standard servo, and we'll call this whatever we want. We'll call it a finger or something. Maybe it's a finger to move around the rolling tubes. Yeah, so if we go over here, you can see our sensor setup. It uses the same ports as our motors. So as you can see here, there's an external controller using up S3 as we set up. And then here you can specify different sensors. So let's say we have a Lego touch sensor. And let's say we have a Lego RGB sensor. And let's say we have, so the IR seeker is High-Technic IR Seeker 1200. If you have the newest model, I believe there's like an older model, or this might be just, I don't even know. I just like 1200 and it works. that has worked for the past like 4 years. So yeah, I just like that. And then you can give your things names. So touch, oops, color. We don't want to name the controller. And then let's call this IR Seeker. Alright, so if you hit apply, you'll see in the code it generated a whole chunk of crap. You don't need to worry about this at all. RobotC, as you can see, automatically generated by RobotC Configuration Wizard, which is very nice because this is, I mean, I can sort of understand it, but I would not be able to write this myself, and that'd be very annoying. So yeah, let's go through the sample program here. Okay, so you can read the comments if you want. I'll just explain what's going on. So the hashtag, or not hash include, basically sort of like tacks on a whole nother file that this program can refer to, which allows us to do more stuff than we were able to before. So joystickdriver.c basically handles the joysticks and stuff, so we can use joysticks if we want, which is very nice. Initialize robot. So in the rules of FTC, I do believe if you put your robot down and you start running your code, you can actually have your robot extend before autonomous starts. Don't quote me on that, but I believe that's what this is for. So basically, in between these two brackets, imagine this as sort of like a chunk And the stuff that the chunk does is in between these curly brackets here. So if you want like your servo to move outward, and you can't just have your robot set up like that to start with because it goes outside the 18-inch mark, you can just sort of put that in here, and it'll run that code. We're not going to put anything in there right now though. Okay, so if you go all the way down, it will say task main. What this is a task is something that the brain will run. You can run many tasks at the same time, but the main task is something special because this is what the brain runs automatically. Like if you send this program to the brain, it will do whatever is in this chunk in between these two curly brackets. If you want to run another task, you can write your own, but you have to tell the brain to run it. It won't automatically run it. Initialize robot is basically referring back to what we wrote back here. So if you put stuff in here, it'll basically run that chunk of code down here. Wait for start. That's from the joystick driver.c program. And that basically, so when you put your robot down, or if you're controlling by Bluetooth, the fuel control system specifies when your robot begins moving. And so this basically says stop until I get that signal from the fuel control system. And then down here, so what's going on here, I'll format this a little bit nicer so you can understand what's going on. So this is called a while loop, and what this does is when you're writing code, think about the brain sort of starts at the top and goes to the bottom, and if it gets to the last line and it has nothing to go back to, it will just stop. What a while loop does is, let's say there's stuff. Okay, let's say there's stuff in here that we put in there. Basically what this does is the brain will start at this line, read this line, do the stuff, and go to this line and say, oh look, this chunk ended, but I'm in a while loop. And so in here they put a true. So if the statement in here is true, another example will be 1 equals 1, and I'll explain what y is 2 equal signs later, but like the same thing would be if 1 equals 1, which is true, loop through these lines of code in this chunk for me. And since it's true, it's always true, it'll just do it indefinitely until you hit the little gray button on the brain. You can have it stop under certain conditions if you put different stuff in here, but for autonomous, basically while true is used because you want to, usually there's a loop of things you kind of want to do. I do have some autonomouses that don't use this, but most of them do. Okay, so let's write a little bit of stuff, just some very basic things. You don't really need to know too much programming for this. You can basically copy what I'm writing down. Okay, so if you want, I talked about setting motors positive values before, and the way to specifically do that is quite simple. You just write motor. You'll notice it's kind of blue. I mean, this RobotC is like, it's a special word, so we can't call, like if we called this motor up here motor, RobotC wouldn't like us because it's already started using the word motor for something else. Then put 2 square brackets, and then put the name of the motor inside. So let's say we want to give power to our right motor here. So we'll just put right in here. Alright, and then put an equal sign, and then the way this works is that if you put a 0, it'll give the motor 0% or a break, and then it goes up by percentage. So if you give it 1, it will go at 1% power. If you give it 100, it'll go at 100% power, and that's the fastest you can go. If you give it negative 50% or negative 50, it'll go at negative 50% power, or sort of backwards. So let's say it's kind of dangerous to go over 75. So we will just give the motor 50 in this case, which is nicely below the sort of dangerous point of the motor. So what this will do, it will send 50% power to our motor, and since it's in a while loop, it'll just sort of keep on going. So this motor is going to get 50% power until you hit the little button on the brain. So yeah. So if you right now, if you hit robot and compile program, you'll notice nothing happens, which means this program can work. That doesn't necessarily mean that it'll do what we want. Very often does the program actually like physically work, but it doesn't actually do what we want. So I'll show you what an error looks like. So if I remove the semicolon, and then if you want to, instead of hitting robot and compile program, you can just hit F7. Alright, as you can see here, there's a little yellow X next to this line. And if you look down here in the error menu, it says warning, semicolon expected before close bracket, automatically inserted by compiler. So there are two types of errors. Yellow ones are basically a warning that the program sort of had to add something for you or do something for you to get the program to work, and it's sort of just guessing. So yellow errors are still pretty bad. And I'll show you, there's also a red error. So let's say we forgot the R, and we compile again. That's weird. It really yells at us. So we get this pop-up message. There's a big red X next to it. So let's figure out what's wrong here. If we read through here, undefined variable modo. Basically, the program has no idea what to do with this modo thing. And that's our problem here. And then we still get this yellow error. It's still trying to supply a semicolon for us. And I'll explain what all these things mean in the next episode when I get into more of the programming aspect. But that's just sort of showing you what an error looks like. So if you fix these, there you go, no more errors. Now if you want to send it to your brain, hit compile and download program, which is F5. I don't have a brain with me, but what will show up is sort of like a little dialog box, and you can sort of close that, and you can, if you're connected to your brain, go to joystick control FTC. It's gonna yell at me here, but so as you can see here, you can connect your joystick up. I think this, I forgot what it's called, but it's basically just a Logitech like gamepad, and you can select it. Whoa, that's a bit weird. Okay. So if you look at here, basically, yeah, I get it. Okay. Oh no. Okay, whatever. Basically, from that little menu, you can start and stop programs, sort of like the field control system can do. You can select programs on the brain to run and all that good stuff. Since this is a sample code, we can't really save it as is. So if you hit Control Shift S, cancel. Save as. It should. Oh, Control Alt S for RobotC. So if you do Control Alt S, basically you can save it to wherever you want. So let's save it to the tutorial thing. Okay, and then you can name it whatever you want. We'll call it sample auto .c. Hit enter. It'll save it for you, and if you can compile again. RobotC, I think by default, whenever you try to compile, it tries to save. I changed that in my preferences, I believe. If you go to detailed preferences, I forgot where, but if you try and compile it, it'll try and force you to save it, which is a bit annoying. If you want to get this whole gamut of options here like I do, go to Window, Menu Level, Super User, which is basically like full control of the setup, and that's what I like best. But if you're kind of like whatever, basic is perfectly fine. You have full functionality. So yeah, that's about all I got for this first tutorial. I should be recording the second one soon, and stay tuned for that. And yeah, for the next one, just go watch some videos on like basic Python, so you can understand like how to write things and what a line of code does. And so it's just Python, sort of like the snake. Python is basically the simplest programming language out there. It's very similar to C, which is what RobotC is written in. Yeah, it should be pretty good. And yeah, that's all I got. I'll see you next time.